Okay, so our last speaker is Al Sanders. Al is a lead developer with Hewlett-Packard. Amongst other things, he manages the NFV infrastructure lab there. So he's going to talk about evaluation and characterization of NFV solutions on HP platforms, I believe. Right?
That sounds right, yep.
Do you then?
All right. Thanks, everyone. Yeah, and I'm not actually a lead developer. That slipped in there. I try to get that corrected, so I'll just take care of that misnomer right away. But I've got part of our engineering team out there in the third row, so if we get questions too technical, I'll just do a pass-through function straight back to them. But so yes, as Tim said, I manage our NFV infrastructure lab and our HP servers telco division. That's a division of HP servers really focused on the telco marketplace. And today will be a little more, we'll end up here with a little more of a practical focus, not quite as technical, but really just talking about how we're trying to bring NFV solutions into the marketplace with as broad of a set of configurations as possible. So I think a lot of the discussions around bringing DPDK, with as broad a set of vendors and so on, we're very interested in that. And so we'll talk some about that today and what our lab's doing to help make that happen. So agenda for today, we're going to just start off kind of giving some background as to how our lab got started, our focus on packet processing. Then we'll talk about just sort of the standard test plans and configurations that we tend to do with the various configurations that we work with. Discuss a set of test results that we've worked. We have a partnership with Intel's Open Network Platform Group, and we'll show some of the results that we've got with that and some of the findings we've found and what our sort of future plans are in that area. And then also another partner that we work with is SixWind, and we'll discuss a benchmark that we've done with them as well. And so talk about our packet processing initiative to start with. So why is HP doing this? And this is kind of the standard slide motivating how NFV is really allowing a move from proprietary purpose-built hardware for network functions onto more standard platforms. HP, of course, is a seller of standard platforms with a long history of working with the telco industry. We're very interested in that. NFV is exciting to us because it really looks to be expanding the available market for servers into the telco space. So we really were interested in NFV, as soon as we started seeing this architecture start coming into play. And my group has been involved in the telco part of HP servers for quite a while. What we've been doing historically is worked on some custom versions of the Debian operating system for external and internal telco vendors. So when some of the distinguished technologists in the server group and really looking at how to maximize NFV adoption started looking at that, one concern they had was at the infrastructure level, at the low level, is anyone really putting that together, at least within HP, making that, validating that, all these NICs and OSs and libraries and all that are going to work together. My team sort of having that low-level software experience within a telco focus was a natural place for that activity to happen. And so we got asked to start investigating that, and out of that, we've kind of grown and built a whole lab environment around that function. This is kind of a standard marketing slide, but the real focus here is just to show that we've kind of had a strategy of taking our standard off-the-shelf servers into the telco marketplace for a long time. Probably 7 or 8 years ago, we made a strategy decision to get away from specific carrier-grade SKUs and more into just taking our standard rack-mount, our standard blade servers, and doing what it took to get those into the NEBS testing environment. So we started offering them, our standard servers with the DC power, the minus 48 volt, and also a peer of mine, John Malloy, manages a group that is really focused on getting the NEBS certification. So doing whatever, taking our servers, running them through the temperature, the electrical, blasting them with fire, whatever you have to do, to prove that it's going to be valid for a central office, and then running the third-party certification efforts so that we can show that our servers are involved in that. And we've been involved with efforts like OpenSAF and OpenHPI, and so NFV is sort of a standard or an obvious kind of follow-on for us in this area. So my lab got formed, and I call it the HP Servers NFV Infrastructure Lab, and I do want to focus on the infrastructure part of that because we have other groups working on full NFV stacks, and you know, as a server division, you know, we're really just wanting to kind of focus on that lower level of things, and so the idea is that, you know, we're going to work with a lot of technology partners to make sure that their various technologies are going to run well with our servers. And really, you know, kind of looking at packet processing as sort of the key underlying benchmark that's going to enable, you know, the kind of performance that you need to run virtualized network functions on top of the stack. So, you know, our focus is really, you know, operating systems, NICs, drivers, SR-IOV, hypervisors, vSwitches, and we kind of see ourselves as kind of a neutral ground for all these vendors that come and work with us. You know, and we're not interested in, you know, it's not a competition. We're not trying to say, oh, this one's better than the other. We just want to work with each of these vendors so they can feel safe coming to us and, you know, getting early versions of the software, working through the problems with them so that, you know, they're each individually able to maximize their performance using NFV. So, as I say, kind of that neutral ground function is really what we're trying to perform here. So, you know, we also do some standard, some typical customer proof of concepts and demos, but really our focus has been kind of working with both NFV partner like stack providers as well as a lot of the different NIC vendors that are out there. And, you know, HPE does have an open NFV group that's really focused on providing a complete integrated software solution for NFV, and they're a strong partner of ours, and they really look to us to ensure that, you know, the infrastructure part of their reference architecture is performing well, and then also to see that, you know, of the folks we're working with, you know, which ones have been proven to be capable of you know, supporting that kind of that part of the architecture. But we also work with other folks as well, as we'll see here in a slide or two. This is the typical Etsy architecture slide, and I just use this slide when I'm talking to folks to kind of really distinguish what the area of focus for us is. So we're not really getting involved as much in you know, the higher level you know, the manageability aspects of it or the orchestration piece of it. You know, we have groups that are doing that, but we're really kind of down in the guts of it. So I just like to, you can kind of think of it as being sort of living within the compute node of the NFV architecture. So really focused on, you know, how does all this stuff play, you know, at the operating system and driver level. So moving into sort of our test plans and the configurations that we run. Really 3 standard configs that we work on, and I'll discuss these more in detail in a second, but, you know, we working on the host space, just kind of the raw, you know, tied in directly with the operating system, you know, what's kind of the maximum performance you're going to be able to get in that configuration. Then moving into virtual machine-based areas, one using SR-IOV and pass-through to kind of tie the virtual machine directly to the virtual function on the NIC, and then moving into the accelerated vSwitch type of operations. For our test cases, I mean, we have worked with the ONP group, the Open Network Platform group with Intel, and they put out a nice benchmark test report as they do various versions of their ONP server, and we found that a good model to follow. So that's really, we kind of took that as our framework for testing. And so, you know, there's a number of different cases, you know, and kind of based on the L2 and L3 forward test programs that come out with as part of the DPDK distribution. But we know we'll kind of start off doing a host-based version of that. We'll typically then move into the SR-IOV function, and actually we run into you know, a lot of issues working with folks, just making sure that SR-IOV and the VM functionality is working properly there. And so that's been a kind of a rich area of work as it turns out, and kind of interesting. Then we'll typically start getting to OpenVSwitch and moving into this sort of the host-based OpenVSwitch, where it's really just kind of dealing with the vSwitch, you know, dealing with the routing table as an L2 forward type of function. Where we're really kind of just now really starting to get into, and we'll talk about that in a second here, but as what we really see as the most interesting aspect of this, and what's going to be the most realistic number, is when you start having, you know, VMs actually routing through the OpenVSwitch, and there's kind of some new interfaces and technologies coming along for that, so we're just now starting to get into that aspect of it. This is kind of talks about our lab configuration a little bit. We have 2 locations. Our primary location is in our Fort Collins data center. We've got about 6 racks of equipment there. Just a various combination of rack mount and blades. We typically have, you know, a set of servers dedicated for each piece of hardware. So, you know, for each NIC vendor that we work with, for multiple OSs, so we're not always having to go out and reconfigure things. We just kind of try to get a dedicated set of servers for each primary configuration. We also have an auxiliary lab in Palo Alto here as well, with a few team members and a couple of racks set up for that. They're the ones that are primarily working with our Open NFV business unit to validate their configuration. We have a variety of server hardware. Really, our focus is on our DL380 and 360 rack mount servers, and then our BL460 blade servers in the C7000 enclosures. We've also done some work with Moonshot on some of the Xeon-based cartridges, and that could be an interesting platform for future development. For instance, if does turn out, we heard some talk this morning about ARM-based solutions for DPDK, and there are some ARM-based cartridges for that. So if that were the case, that could be an interesting platform for us to try that out, and we would certainly be interested in doing so. What we've really found is, and really just recently, is that now as this technology is gaining acceptance, there's a number of NIC vendors that are all working to make sure that their NICs are well supported, and we've had the opportunity to work with a number of those, and so that's been I think kind of gratifying that they're wanting to work with us to kind of make sure as a testing ground in our hardware to make sure that things are working well. So we've worked with Intel, both with their Niantic and Fortville NICs, worked with QLogic, Mellanox, Avago Emulex. We've had some discussion with Broadcom as well. So really just kind of showing that kind of multi-vendor aspect of DPDK that I think is important to help make this technology accepted within the industry. Also, and we'll work with any OS that things are working with. So Red Hat, Wind River is our Open NFV business unit. Their OpenStack is based on Wind River technology, and we've had a partnership with them to ensure that Wind River is certified on HP servers. So we've been helping to work with them to make sure that the right drivers are integrated into that software. Fedora, Debian, H-Linux is an HP-developed Debian that is part of the commercial OpenStack offering that we have, and so we've talked to that group some. And then SixWind is another NFV provider that we work with real closely. They kind of provide a complete 6-WIN gate stack that we've worked with and done some benchmarking with, and we'll show some of those test results here in a little bit. We also have the Spirent network test generator that right now we've got, I think, about 5 40-gig ports, which can be split into 10-gig ports, and we'll look to expand that as required. And just expanding on that, we found that that really has been an essential piece of our equipment for the DPDK testing. It's certainly a daunting investment, for a piece of hardware like this, but we'll start off using the software packet generator, the DPDK packet gen, but that can only take you so far, especially as you need to get line rate on higher bandwidths, ahead of 10 gigabits. What we found, it provides us reliable line rate for 10, 40 gig and other speeds next year. Accurate hardware measuring of the packet return timing. Right now we've got 5 ports of 40 gig, and and that still becomes somewhat of a kind of a bottleneck. We have to make sure as we're scheduling our testing that becomes it's not so bad right now with the 10 gigabit because you got the cables that can split a 40 gig port into 4 10 gig ports, but as we start to move into higher speeds, we're going to have to either expand this or figure out a way to better schedule our resources so that different testing is using the ports, and then someone has to go switch the cables around and figure that all out. One thing we've kind of focused on is there's the standard RFC 2544 test, which measures the maximum throughput that you hit 0 packet loss at. So it'll automatically has an algorithm to kind of do a binary search to discover that. It gives us latency test measurements, and then automatically generates all the data reports. So we found this a pretty important part of our lab to allow us to do this type of testing. So some of the results that we've seen, and what we're showing here is some of the results we've gotten with the ONP stack. So starting off, let's talk about the the host-based configuration, and this is just standard, all running within the host, DPDK tied directly to the NIC, no virtual machines involved. So this kind of represents what's the best case scenario, what's the best you can do with the DPDK technology. This example we ran with the Fortville NIC. This is a 4x10 NIC using the I40E driver. And this is just a typical L2 forward throughput test, which basically just a bidirectional packet flow, takes in a packet on one port and sends it right out the other port. No packet processing involved really at all. So as we can see here, well, I don't know if you can see because it's pretty small numbers, but basically what this is showing is that we actually were able to hit 100% line rate for all packet sizes from 64 up to 15, 18 was the highest one that we did. But as we'll see in some other cases, you can often hit the line rate for higher packet sizes, but getting it at the 64 bits is pretty tough. And this NIC was the first one that we were able to see that. Now we did have to experiment a little bit in the RFC 2544 test when you're running with the Spirent and you sort of tell it where to start at its load rate. And this is just kind of stuff we kind of learned with experimenting, but as we started with at a higher load, it would fail and then it would drop back down. It would never, somehow the algorithm would never get back up to the 100%. And then when we dropped that down and started at like at a 70% load, then it managed to work its way up and find it, and it actually was able to pass at the smallest packet level. We've seen some tweaks there, and we're working kind of back and forth with the NIC team to figure out what the right tuning variables are. We find there's just a lot of different settings and all that we're having to work with, and we're still working through that. Like in some cases, we've actually found that when you first started it up, it's almost like having to set the choke on a lawnmower, right? When you first started it up, it didn't seem to go quite as fast, and then it started going. And I'm not sure why that was, but I just saw today where we got some requests to do some settings to play with that. So this is just an example of kind of some of the back and forth that we have with the vendors to try to get the results. But and the other thing that we found too is that if you just take the L2 forward straight out of the DPDK.org distribution, we weren't getting quite as good numbers. And then if you look in the benchmark test report, they actually have some tuning guidelines in there in one of their appendices that talk about expanding some of the, increasing some of the queue sizes, the receive and transmit queue sizes. And we actually found that when we followed those, and that seems like that applies for any 10 gig NIC, in fact. So yes, question? With what, I'm sorry?
The starting problem that, if you start at full line rate, then it doesn't really, RFC testing doesn't really go through so well.
Yeah, the question is why is that when we started at a higher load level? And I'm not really sure. I mean, that's a quirk of the algorithm and the Spirent as to, it could be an issue with how that, because it seems like it should be able to find that in any way. I don't know, Lee, did you have any thoughts on that? Yeah, it was a surprise to us that we kind of stumbled upon by accident, that it's like, oh, we're not quite getting there. It's like 97%, right, or 99%. But and then our tester, she dropped back to 70%, and it's like, wow, we actually hit it. So that was a little bit of a surprise. Yes.
Does the L2 forward tool spin like at 100% waiting packets, or does it do some sort of delays in targeted packets? So if it is doing that, then it might be that initial burst of packets causes it to drop and it's ready to handle it. But if it's ramping up,
that could be. Do you know, does the L2 forward start off with an initial burst, or is it just? So I guess the question is, could that be actually an aspect of the testing itself?
It's sitting there spinning.
Right.
It's in a Volvo driver, and at some point you turn on the siren and it starts sending packets for 2 minutes an hour, or however long it runs.
Excuse me.
Yes.
I've seen this problem with other customers as well.
Okay.
The problem you're seeing is your initial loading of the cache within your product, with Fortville, etc. So as it's learning the addresses, it runs slower as it's doing the initial learning. So if you tell the tester to start at speed, it fails.
Yeah.
And when it fails, RFC 2544 testing is going to test lower until it succeeds.
Mm-hmm.
Not say, well, the first one might fail. So it's the algorithm of the 2544 test. And it's all the learning on the initial, which is why you don't start at the line rate.
Right. That makes a lot of sense. So I don't know if folks can hear that, but because the way the 2544 does its binary search, if the first number you start at fails, it's not going to go back above that. It's going to, take the halfway number and then work its way back up to that. And because of the, as he was saying, if your cache is missing initially, so that if you start off too fast, so that you're getting failures at the cache rate, then you're not going to see that. If you drop it back down, so that the cache effects aren't going to keep it from failing, then you're able to work its way back up. The cache is filled up, and now you're going to get better results. So that makes a lot of sense. Thanks. Yes?
Did you record CPU utilization to actually run at line rate? How much CPU power you're using to ingest and spit back 40 gigs?
The question is about CPU utilization. I don't know if we've measured that yet in our testing.
Well, it's using a DPDK Bobo driver is using the processor 100% full,
Right.
Right. I mean, it's sitting there spinning. We haven't measured as far as how much idle time it's actually spending when it's actually no.
So yeah, so we're dedicating the core to the test, but we haven't actually measured any idle time on that. Okay. This is an example for our latency numbers. Now this showed one of the cases where we started it too high, and then it just kept dropping itself back down, so it only got to about 98%. And what we found for the Fort fill, we actually got about 10 to 20% number improvement for average latency. Then we got over the Niantic. We were kind of in the 7 to 9 range here on the Fort fill, mostly in the 8 numbers. I think the Niantic was more around 10 microseconds. But one thing we found is a lot of variability in the maximum latency, and that's an area we still need to study more, because it goes anywhere from 16 to 49 up to 100 microseconds, and I know that's a key number for vendors, is what's the maximum latency you're going to see. So it's a little odd that we're seeing those kind of spikes, and so I don't know if other folks have seen that sort of thing. And by the way, this is great. I'm definitely interested in having interactive conversation here on these results, and if other folks have seen things like this. But so that's a question we still have that we need to go study some more by playing with some of the core allocations and so on. Yes. Have you done any isolation for the CPU cores from the kernel? Yes. Yeah. We will do that. Yeah. That's about isolating the CPU cores from the kernel. Yes?
First question that talked about using CAN or CMP to use, say, DDO to give the packet to the empty cache. Have we done any other optimizations before running SR forward on to explain the max latency?
Yeah, we have not done a lot with cache optimization yet, but I think that, especially based on the other, and then I also heard some talk about some of the CMT and CAT technology, although I don't know that we have any of the processors that support that, so we would have to get some of those processors to try that out. Okay. So then, yes.
The throughput numbers you mentioned, are these for a 0 frame loss for a small frame?
For the frame size you're asking?
The throughput was measured with 0 loss, or was it with a small?
Yes, because we start off, so with this, with that 2544, it'll figure out the highest load that it can offer with getting no packet loss, and then it does its test at that point. We'll see in a second some other cases like with Niantic where you don't get there for the smallest packet size, you only get to about 78% load, and so that's what we would offer. But in this case, we were actually achieved 0 packet loss with 100% load with the 64-bit packet size, and then all the way up. So then moving into the SR-IOV based, and again, I think folks are familiar with this, but it's just using the SR-IOV to set up a virtual function on the NIC and then the pass through from the VM straight. So bypassing any vSwitch here at all. Now this number here is running with the Niantic NIC, or the HP560 adapter. And what we found is that you basically, except for the smallest packet size, you basically hit about the same performance that you do with the host base. So you're in a VM, but you're still getting pretty much line rate performance, except for the smallest packet size. So in this case, I think it only got to, looks like about 78% load. You're getting about 23 million packets per second, where line rate would be 29 million. But everything else, 128 and above, it was able to hit line rate. So part of that is just showing how the Niantic didn't quite have the small packet performance. And I'm not sure we would need to see if we also measured that Niantic with some of the cache considerations that we had, starting the load high enough. I'd have to check on that. But I think just in general what we found is that the Fortville had a little better performance there. One thing we found, we also, there was some discussion earlier today about the huge pages. And when we first started running this SR-IOV test, we kept seeing this, instead of the standard curve that starts high and comes down, there was sort of this dip that, started off. But before we were just kind of doing just straight, packets per second measurements. And so you'd kind of get this jump and then it would come back down. And we couldn't figure that out and finally realized that the 1 gigabit huge page size setting was not getting honored within the VM, so that the IOV table was getting overloaded and it was causing a lot of packet loss. I think in Red Hat 7, they actually implemented the true 1 gigabit huge page sizes within the virtual machine, and once that started coming into play, then that effect went away. So making sure that those huge pages are set and that they're working within the virtual machine environment was a key aspect for this kind of test.
Can you tell me which software component was failing to honor the huge page thing? Was that the hypervisor?
Which piece of it was not getting set?
Yeah, I think the hypervisor. Certainly the VM wasn't having pages all the way through to the host. So probably the main part was the hypervisor.
Okay.
I suppose the extended page table is not like that much.
So really what we're just kind of starting to get into now is the OpenVSwitch testing using the OpenVS DPDK NetDev. And all I've really got to show today is just the host OVS results, and this is just really measuring raw OVS DPDK performance, kind of similar to what we had with the host-based L2 but using the accelerated OpenVSwitch as in place of the L2 forward application. And what we find here is that the small packet performance is, and this is also with the Niantic, by the way, our small packet performance is quite a bit worse. We're hitting like 59% load instead of the 78% load that we saw with the SR-IOV model. But really everything else, we're right at line rate for the higher numbers. So, I've seen some studies with standard OVS, non-accelerated OVS that were showing about 2 million packets per second at 64 bytes, and here we're at about 17 million. So, that's showing, that's a clear example of the benefit of the DPDK acceleration here. Obviously, what we want to get to next is some of the VM, actually forwarding packets from VM to VM through the vSwitch, and I'll talk about that in our future study areas. Another example of a DPDK vendor that we're working with is the 6Wind, and they've done a benchmark with us on our 580 servers, and the 580 is just a bigger version of the 380, which allows you to put more, so you can load that thing up with 940 gig NICs and get a lot of network bandwidth through there. So, Emery Eltron from 6Wind is here. He's the one that did these benchmarks with us. So again, if we have questions on the details of the 6Wind implementation, I'll pass that on to Emery. But this is talking about, they have a virtual accelerator product that uses DPDK in a number of cases. 6Wind, they're I think well known in the DPDK community. The DPDK.org maintainer is from 6Wind. They do a lot of work with POMO drivers as well as their 6Wind gate software. So in this case, they've got their physical NIC drivers. They've got DPDK VirtIO as well as part of this accelerator implements an accelerated vSwitch along with some other capabilities as well. So just kind of take you through that. So they did a test, first of all, and you know, one of the things they're measuring a lot is core utilization required to achieve a certain amount of bandwidth. So kind of with the standard OpenVSwitch, standard IP forwarding, and Linux, and you know, hooked up to the traffic generator, they were getting about 7 gigabits per second, and having to use, I think in this case, let's see, it's like, well, anyway, 80% of the available cores, it was like there's 24 cores, so what's that, 18. So 20 of the cores they had to use for the hypervisor, which limits the number of cores available for the processing within the virtual machine. When they then took their own virtual accelerator in there, and then also they have a turbo router application to do routing in the virtual machine layer, they were able to achieve significantly better performance with much fewer cores as well. So now there's only 4 cores allocated to the virtual accelerator, 2 for the turbo router, which you know, leaves a lot of cores remaining for processing with much better. So this is a case, again, another partner of ours and some other benchmarks that we've been running, and examples of how DPDK has been able to provide a lot better performance. So future study areas, obviously, you know, a key thing we really want to get into, and I was hoping I'd have some of these numbers today, is kind of getting into more of the VM testing configs, because I think this really represents, you know, much more realistically what an NFV application configuration will be, and kind of get a sense of what an NFV architect could expect, you know, in this kind of configuration. You know, one of the aspects of an SR-IOV, you know, you're in a VM, but because you're locked down to the virtual machine, to the virtual function, you're not able to do any kind of migration or anything like that. In some cases, that's okay, you know, if it's a short-lived application. You know, vendors will say, well, that's fine, you know, I'll just, you know, if I need to move the VM, I'll just drain one and start up another one. But in other cases, you know, people want to be able to do that kind of live migration, and so you need this sort of configuration in order to do that. So the testing configs that we want to work with are, you know, both through a single VM and then through VMs in series and also in parallel. What, you know, we found is kind of, there's a lot of different configuration options here, and it seems like things are really moving to the vhost user interface. So in order to do that, you know, we'll have to move to DPDK 2.0 and this vhost user, which I think went into the 2.4 version of the vSwitch, and so we just haven't had a chance to get all those newer versions put together yet for this testing. So that's kind of our next major step that we'll be working on. But there's some other things as well. I mean, obviously, you know, the L2, L3 forward is a pretty basic set of tests, and we'd like to kind of look at, you know, typical VNFs and what kind of load do they put on the infrastructure level, and are there types of testing that we could do that would, you know, better model that. One thing we're really interested in, because, you know, we really have a focus on kind of taking our NIC roadmap and then, you know, making sure that, you know, those are, what does it take to utilize those in NFV environments. And so as we work with all of our various NIC vendor partners, you know, there's the getting above, excuse me, sorry, getting above 10 gigabit is certainly going to be interesting. You know, in our Blade environments, there are a few of the mezzanine and LOMs that can do 20 gigs, and so that's kind of the first thing we'll be looking at. We have done, in one case, we did a 40 gig NIC testing with Mellanox, but that's like a PCI X8 card, so you find in PCI 3 X8, you sort of max out at 58 gigabits. I think you don't get the true 80 gig you'd be expecting to see, so newer versions of those cards that are X16 will be of interest. And then we're really excited about the 25, 50, 100 gig series. We kind of think that's going to maybe take over from the 40 gig, and so you know, we've got some of those examples coming out next year, and are really interested in playing with those and with the DPDK POMO drivers. Looking into some of these latency results that we talked about, the maximum latency is things you want to understand. Certainly, as we work with some of the various Intel processors, there's a lot of interesting things there with core, you know, core utilization, NUMA zones on the NIC and all that. Those are things we'd like to try. Yes. Sorry.
Customers talk to us about the maximum latency going up as well.
Yes.
And we found 2 reasons on most of them. First, if you use CPU 0, core 0, the interrupts come in core 0 no matter what you do.
Okay.
That pushes your latency out.
Okay.
And the other one, standard NFV lets lock the core, doesn't lock the OS out the core. So even though you're locked into the core, occasionally the OS comes in,
Okay.
grabs time out, and that tends to give you the
that's great to know. Because I know we're doing CPU 0 testing, is that? I'm not sure. Yeah, that'll be something to look at. I might catch you after the meeting. Yeah, thanks very much. Appreciate that input there. And then the final thing I was going to talk about, and this isn't really a technical aspect as well, but it's one that, as we kind of look at taking these solutions to market, we're really starting to struggle with, and that is the support strategy for this various versions. As one thing we found as we work with each vendor, it gets very complex into getting, the right versions of the firmware and the driver and DPDK and the OVS, and getting a combination of that's all going to work together. And so as a platform, so like for example, our OpenNFV group right now, so they have a bundled software solution that they put out there, with a certain version of Wind River and their Helion carrier grade OpenStack and DPDK versions and so on. Well, so what happens? Say that's got DPDK 1.7.1 in there, and some sort of a bug comes up, and the NIC vendor has to say, well, you need a new version of this driver, but it only works with DPDK 2.1. The telco vendors we found, they really like to have a very stable software environment and not make major changes to that. There's actually cases where Debian, we're supporting versions of Debian that are like 5 versions old for some vendors. So we're kind of struggling with the model right now is just a top of tree support model. Is that well, if there's a issue there, well we'll see you at DPDK 2.2, right? So there's kind of just a practical aspect of that as how are we going to deal with that, bug fix support and so on. Typically right now, we work with the vendors to provide that support, and so we're really promoting, encouraging these vendors to work through dpdk.org to do their pull mode driver distribution, as we think that's really the right place for that to be, rather than off of some proprietary website or HP website somewhere. But it's just something we're kind of struggling with, is to really understanding, how do we create bundled solutions that can be supported, and then how do you do defect fixes for those, and build support for that or not. So that's an area that I'm really kind of struggling with, and if anyone had any ideas on that, I'd be interested in chatting with you about it.
Yes. I think that's the whole point of what the push for 2.0 was for the AVI versioning, right? They have the idea that when you run a version, you have those little symbols available, so you don't run into that issue, right? Because that's been the fundamental problem with DPDK, is it sort of willy-nilly been changing from release to release, and there's sort of no consequence. Well, we'll make a change in 1.8, from 1.7.
Right.
And then,
we struggle with that a lot.
The application vendors pay for it, right?
Yes.
Because they sort of have the tendency to rewrite the app, and that shouldn't be the case. And I think the community as a whole should really focus on moving forward with guaranteeing that API and that compatibility. Otherwise, really, DPDK is not going to have as wide adoption as it could.
Yeah, I totally agree. That's kind of what and that's good to know about the that capability in 2.0. So we'll definitely look at that for support, but. So I guess just at the conclusion, just to say that, so our lab's really been focused on, demonstrating viable performance, with a broad range of configurations on our platforms. And I think we've, been able to show that, the DPDK technology does indeed enable the kind of performance that's required to support the data plane demands of NFV. We've found that the number of network and NIC vendors that are looking to support this is expanding rapidly, and we've certainly been encouraging them to work with the DPDK community and dpdk.org to distribute their drivers. And so we're really committed to working with as many hardware and software partners in the community as we can to promote broad industry acceptance of this technology, because we think it's really promising, and it's going to really allow us to expand our presence in the telco marketplace. So we're very excited about it. Any other questions? Yes. So I think for the data, as I see myself as kind of a neutral partner working with the vendors. So we're not going to be marketing the solutions for the different partners, but I mean, we would certainly work with them as, you know, they feel like they've got results that they want to publish. You know, we would certainly work with them to promote those, but I think, you know, we would probably look to the, you know, work with the vendors themselves to do that. I don't want to get into like a competitive thing to say, you know, oh, here's 5 different NICs and, you know, here's who's great and here's, you know, I mean, because I mean, all these things have different capabilities, right? You know, some really focus well on data plane performance, but others may not do quite as well as that, but they have a lot of very interesting, you know, offload technologies and so on that could come into play. So we're trying to, you know, I mean, we'll do white papers with vendors. Like, you know, we're working on I think a white paper right now with the ONP technology, and, you know, we would certainly do that with other vendors. But I think we'll do that in conjunction with the vendors so that, you know, they can promote that when they feel like they're ready to do that and make sure that their, you know, their marketing message or whatever, you know, is adequately presented. I don't want folks to feel burned because they've come to me, you know, to work with them, and then, you know, we publish, you know, numbers that don't look so great, and then, you know, that would be kind of, but yeah, so we'll definitely do that, but I'd say in conjunction with the, you know, with the partners and at their discretion. Yes.
Have you done any measurements where the vSwitch uses DPDK, but the VM doesn't use DPDK?
We have not done that currently. Well, I mean, really haven't got even into, you know, we kind of ran into, you know, kind of getting into the, you know, the latest version with the VOS user. We're kind of waiting on the ONP 1.5 in that case, you know, which I think will support the DPDK 2.0 and the 2.4 that we need. So we really haven't gotten into the VM plus OVS at all, you know. So yeah, so we haven't had a chance to do that. But yeah, that would be, I guess, an interesting variation to try that, and then, you know, as well with DPDK in both cases. I think what we were planning to do would be a DPDK app in the VM, you know, running through a DPDK accelerated vSwitch. But.
Can you share the slides?
Yes, they're out there with. So the website that Jim posted, these slides are available there. Yeah. So. All right. Well, thank you, everyone. Appreciate your time.